Welcome to the capabilities of generative AI. After watching this video, you'll be able to describe some of the capabilities of generative AI and explore their use in the real world. Let's start with a high-level overview of some of the capabilities of generative AI that we'll discuss. First is the text generation capability of generative AI, that is, its ability to generate clear, lucid, and contextually relevant textual responses. The second capability is image generation, that is, synthesizing artistic and realistic images that are very similar to real ones. The third capability is audio generation. Generative AI enables music composition and synthetic audio generation. The fourth capability we'll discuss is video generation. Generative AI enables the generation of dynamic films and small videos based on textual descriptions and even images. The fifth capability is the code generation capability of generative AI. Generative models can generate code, functions, and programs. We'll also discuss the data generation and augmentation capability of generative AI. This helps generate synthetic data to create and augment data sets. Finally, we'll explore generative AI's capability to create real and immersive virtual worlds. These are just some of the capabilities of generative AI. Essentially, whatever the human mind is capable of conceiving is a potential use case for the application of generative AI. Now, let's delve deeper into some of these capabilities. Let's begin with the text generation capabilities of generative AI. At the core of generative AI's text generation capability are advanced AI-powered large language models, or LLMs. LLMs are trained on large data sets and can generate human-like text in various contexts. These models learn patterns and structures within the data to generate coherent and contextually relevant responses. These models generate text, converse, and provide explanations, summaries, and more. Some popular LLMs are OpenAI's Generative Pre-trained Transformer, or GPT, and Google's Pathways Language Model, or PaLM. These models can perform various language-related tasks such as text completion, summarization, question answering, translation, code generation, and image and text pairing. Conversational interactions with chatbots and virtual assistants are powered by LLMs. Let's look at the image generation capabilities of generative AI. Generative models can generate high-quality, convincing images based on deep learning techniques such as generative adversarial networks, or GANs, and variational autoencoders, or VAEs. These generated images exhibit realistic textures, natural colors, and fine-grained details, giving the impression of a real camera capture. StyleGAN, for example, can generate high-quality, high-resolution new images of imaginary faces, animals, or nature, while DeepArt can create comprehensive artwork from a simple sketch. DALL-E can generate entirely new images as described by the users. Apart from applications in art, design, entertainment, gaming, and research domains, generated images can augment training data and aid medical imaging and scientific visualization. In the context of audio generation, generative models can generate new musical compositions, convert text into audio using text-to-speech, or TTS, and create synthetic voices and natural-sounding speech. Generative models can convert, modify, and transform and clean up voices, also reduce noise and enhance audio quality. These models also have the capability to mimic human voice to a fair amount of likeness. WaveGAN, for example, can create new and realistic raw audio waveforms including speech, music, and natural sounds. MuseNet from OpenAI can combine various instruments, styles, and genres to generate novel musical compositions. Google's Tachytron 2 and Mozilla TTS use advanced TTS systems to create synthetic speech resembling human tone, pitch, modulation, pronunciation, rhythm, and expressions. Audio generated by generative models has applications in media, creativity, entertainment, training, education, gaming, virtual reality, and several other domains. Now, let's look at the video generation capabilities of generative AI. Generative AI models can create dynamic and lucid videos ranging from basic animations to complex scenes. These models transform images into dynamic videos by incorporating temporal coherence. In natural language processing, temporal coherence refers to the consistency and continuity of meaning or context over time. This enables these models to exhibit smooth motion and plausible transitions in videos. For instance, a popular AI model, VideoGPT, follows textual prompts users provide to generate new videos. Users can specify the desired content and guide the video generation process, including completion, editing, synthesis, prediction, and style transfer. These generated videos can be used in domains such as art, entertainment, education, gaming, medicine, and research. Now, let's talk about generative AI's code generation capabilities. Generative models can generate new code snippets, functions, or complete programs based on desired functionality. Trained on existing code repositories, these models can complete or create code, synthesize or refactor code, identify and fix bugs in code, test software, and create documentation, including comments, function descriptions, and usage examples. For instance, GitHub Copilot and IBM Watson Code Assistant are AI-based programming assistants that help autocomplete code, accelerate hard tasks, and generate code for provided input. AI-generated code can be used in software and web development, machine learning and natural language processing, data science and analytics, robotics and automation, virtual game and AR/VR environment development, and audio, video, and speech processing. Software developers can benefit from leveraging code generation capabilities to write, debug, and test their code. Now, let's explore the data generation and augmentation capabilities of generative AI. Generative models can generate new data and augment existing data sets. Generating synthetic data sets helps increase the diversity and variability of the data, leading to more robust and effective performance. These models can generate new samples and augment data sets for images, text, speech, tabular data, and statistical distribution, time series data, finance, and more. The data generation and augmentation capabilities of generative AI have applications in medicine, healthcare, gaming, education and training, art and creativity, self-driving automobiles, and many more. Another powerful capability of generative AI models is their ability to create highly realistic and complex virtual worlds. You can create avatars that simulate realistic behavior, expressions, conversations, and even decisions. You can also create complex virtual environments with realistic textures, sounds, and objects that follow the principles of the physical world. Metaverse platforms use generative models to create unique and personalized experiences for individual users. Generative AI also makes it possible to create virtual identities with unique personalities, avatars that can be fitted with specific personality traits that reflect in their behaviors and conversations. The virtual world capability of generative AI has applications in gaming, entertainment, education, augmented and virtual reality, metaverse platforms, and also virtual influencers and digital personalities. In this video, you learned about some of the capabilities of generative AI models and their use in the real world. Generative AI can create coherent and contextually relevant content and generate realistic, high-quality images, synthetic voices, new audio, and dynamic videos. And generative AI models can generate and complete code and synthesize new data to augment the existing data sets. Generative AI models are also capable of creating highly realistic and complex virtual worlds, including virtual avatars and digital personalities.